All right, we got some new terminology today, angles of elevation and angles of depression, but we're going to solve these problems using trig and triangles just like we did in our last lesson. So really all you got to know are these two new terms. So here we go. The angle that your line of sight makes with a horizontal line when you stand and look up at a point in the distance is called an angle of elevation. So if you see my little picture here and you see this little dude looking up to the top of the lighthouse, you can see right here it's the line of sight, it's the angle the line of sight makes with the horizontal. Always measured with the horizontal. So there's our angle of elevation in that case. All right, and then we have an angle of depression, and that's the angle that your line of sight makes with a horizontal line when you stand and look down at a point in the distance. That's called an angle of depression. You know, you can think of it as down, depression. That's the angle of depression. See, like this lifeguard here, he's looking at this swimmer. Here's the thing, guys, that's going to trip you up if you don't pay very close attention here. My angle of depression, you see, just like the angle of elevation, has to be measured with respect to the horizontal. So there is my angle of depression. Right there. It's not the one that you would think it would be. The one that you would think it would be, I think, is this one. That's the one you would want it to be, but no, no, no. It's the one that's measured with respect to the horizontal. So don't forget that. All right. So now all that's left is for us to do some practice problems. Now that we know what each one is, you always have to draw a sketch for these or I'm going to get very angry with you. So here we go. You're measuring the height of a flagpole. All right, here's our flagpole. We'll put us a little flag up here. And we want to use trig to find out how tall the flagpole is. So we'll call that X. You're going to stand 19 feet. So you're going to stand about right here. And that's going to be 19 feet. From the base of the flagpole, you measure the angle of elevation from a point on the ground. So I'm going to use my red so that stands out to the top of the pole. So a point on the ground to the top of the pole. So there it is to the top of the pole, and that angle is 64 degrees. So let's use that to estimate the height of the pole to the nearest 100th. Well, what do we got? We got an angle, we got the side opposite, we got the side adjacent. So clearly that's going to be tangent, right? The tangent of that angle, tangent of 64, is side opposite over side adjacent. So now we're going to cross multiply. 19 times the tangent of 64 is going to tell me about how tall that flagpole is. And when I punch that into my calculator, X is going to be about 38, what does it say, 100th, 38.96 feet. Don't forget your units. So that's all we got to do. And that has helped us to know how tall, about how tall that flagpole is using trig. Okay, what do we got next? We got a hockey player. All right, let's see. He's 35 feet from the goal line. So I'm going to put my goal here. Here's our goal. That's our goal, right? That's a good looking goal. And the player is 35 feet out. So he's right here. This is 35 feet. He shoots the puck directly at the goal. And we're going to assume it's coming off the ground. It's coming off the ground. He's not shooting it from the air. And it says the angle of elevation that the puck leaves the ice is 7 degrees. 7 degrees. The height of the goal. Oh, we know the height of the goal. The height of the goal is 4 feet. Is he going to score? That's interesting. How are we going to find out? How are we going to know? Well, once again, we got an angle and we got a side opposite and we got a side adjacent. So here's what I'm really looking for. I'm really looking for this X, like where is his puck going to hit the net? So what I'm going to do is I'm going to say the tangent of 7 equals X over 35. Right? I could do the tangent of X equals 4 over 35, and then I'd find out what his angle needs to be, but oops, then I would spoil my next problem. So let's do it this way. So I'm going to cross multiply 35 times the tangent of 7 equals x. And when I punch that into my calculator, I get that x is about 4.3 feet. So what is that telling me? Is he going to score or he's not going to score? Well, what's going to happen is if x is 4.3 feet, that's going to give me about 4.3 feet. So nope, no score. His angle of elevation was too large. Okay, based on what I did right there, I want you to pause and do the next problem. It's almost the same, but what you have to do is find the angle. So you do this one and come back and check it. All right, so this guy, he's 27 feet from the goal. He shoots right at the goal. The height of the goal is 4 feet, just like the other one. I guess that's regulation. Somebody will have to tell me. I don't really know. What is the maximum angle of elevation at which he can shoot and still score? So once again, we got the side opposite and the side adjacent. So we set up our trig ratio. The tangent of that angle is 4/27. We take the inverse tangent and we get that that angle is about 8.43 degrees. So if he shoots at any angle larger than that, if he shoots at 8.44, well, he might hit the frame and it might fall in. But if he shoots anything very much over 8.43, he is not going to score. 8.43 is his max. All right, one more and then we're done. We're done for the day. You sight a rock climber on a cliff. All right, let's put a cliff up here. Here's our cliff. Here's our little rock climber. Woohoo, I made it. She looks right into your eyes. So where are you? At an angle of depression. So let's say you're down here somewhere. This is you. Hello. So she's looking down at you. Right? And remember, angle of depression is measured with respect to the horizontal, so that's this angle right here, 32 degrees. Your eye level is 6 feet above the ground. So we're going to sketch in our triangle like this. Wow, you're pretty tall. Your eyes are 6 feet, so I'm just going to label this little part right here as 6 feet. This is 6 feet from your eyes to the ground. Okay, let's see, her eye level is 5.5 feet above where she stands on the rock. Excuse me. So basically, from the top of the rock, I'm going to put 5.5, even though I don't like these decimals, but that's what I'm going to do just in the interest of time here. And for Matthew Brenningmeyer. Okay, 5.5 feet, 5.5 feet. So let's see, you are 1,000 feet from the base of the cliff. So this part of our triangle is going to be 1,000 feet. What is the approximate height of the rock climber from the ground? Okay, this is not a very well worded problem. So what I really want to know is, what is the height of the rock? What is the height from the ground to the top of the rock where she's standing? So what we got to figure out here is, do we have any extraneous information in here we don't need? And I don't know, that makes this one a little bit more difficult. Okay, so let's see. So here's what I'm looking at in terms of my triangle. So I'm going to break myself out a little triangle right here. So if I go from the top of the rock down to that person's eye level, your eye level, okay, that's going to be my right angle. This is, oh, and this is 32 degrees, so guess what? This is 32 degrees, right? How do I know that? Oh, because I'm going to assume that the horizontal that I'm using with, for the angle and the ground are parallel. So they're alternate interior angles. So that means this angle is going to be 32 degrees. I mean, you could call this one 58, but I'm just going to use that one. Okay, so 32, and this is 1,000. And this is what I'm really trying to find, right? How how far is it up to the rock? So this part about her being 5.5 feet tall, that's really not pertinent information to this problem. So sometimes for these problems, you got to figure out what you need and what you don't need. So let's just solve this little right triangle that I have right here. So I'm going to use the tangent of 32. It's going to be the side opposite over the side adjacent. So x is going to be 1,000 tangent 32, which is going to be about 624.9. 624.9 feet. Okay, but now here's something that is relevant to this problem. I'm looking from eye level, right? I'm taking this person's eyes here. So what do I have to do to get from the ground to the top of that rock is I got to add that 6 feet in there, right? So from the ground, because here's the ground, I got to add this 6 feet back in here. So from the ground to the top of the rock, I got to put that 6 feet in there. So it's going to be 0, 3, it's going to be about 630.9 feet. So that's what you got to do. You got to go through these problems and decide what information is relevant and what isn't. And that's how we did that problem. That's all. And don't worry, if you want some more problems to practice tonight, feel free to go ahead and look at your work packet for tomorrow. I have tons and tons of angles of elevation and depression problems for you. But that's it for now, and we'll see you next time.